All right, so in a previous video, I gave you some practice problem questions, and those questions are right here. I gave you two questions and said you can keep working on this with some other problems. I'm actually not going to write anything down for these uh, answers. I've already done it, and I've saved it in my Google Drive. And I encourage my students to do this because if they ever want to look back at it, they have a permanent copy they can look at anytime, anywhere. They don't have to look through stacks of paper. They don't have to worry about losing it. And so I'm going to go and show you what I did when I went ahead to do this. And so I have a folder called Solve 'em. This is a solve 'em problem solving using the solve 'em method. And I have practice problem 1. I put the original question into here so that students knew exactly what I was talking about. And I put a little bit of a note down here, not necessarily tooting my own horn saying, aren't I great? But I wanted to make sure that students knew that I used scratch paper, I used 2 whiteboards. It's not because I had a hard time solving it, I actually knew the answer ahead of time, but I wanted to really work through my problem and make sure that I had a good method, make sure that I had everything that I wanted before I wrote a final product. I'm not saying that this is going to be a perfect paper. It's sufficient. And this took about an hour to write these things out on scratch paper, to write things on a board, to figure out what was important, to organize it. I started writing it out, realized I made a mistake or it wasn't neat, and so I started over, and it took about an hour to work through the process. It took my final write-up took 2 pages, and so I took a picture of them, and again, I encourage my students to do this. I try to make this pretty neat and organized. It was 2 pages, so I put a 1 up here in the corner so that I know that it's page 1. I said this is my practice problem 1, and I drew a sketch, and I hope that this is something that's useful. I drew my 2 circles, and I showed that there's going to be an area and that there's going to be 2 perimeters. I put some variables in there so I knew exactly what I was looking at. I wrote down my assumptions. I put in my observations. I talked about the steps that I should take, that I should find areas. There were 3 areas I needed to find. I said that I needed to find perimeters. There were 3 total perimeters I needed to find. I even put in some notes here to make sure that my perimeter had just length units and then my area had length squared units, and to box my answer at the end. I'm really bad at remembering to do that, and so sometimes I do put a note on there to make sure that I do that. I listed out all my variables, and even when I didn't have a exact value for a variable, I still put it on here and I described what it meant. I put my equations on here. I had 4 total equations, 1 for the area of a circle, 1 for the perimeter, and then how to get a total area, which is, in this case, take my large area and subtract out my small one, and for my total perimeter, I summed up my large and my small perimeters to get the total. Then I did page 2, and I did step-by-step things that I wanted to do. I tried to explain what my step was, what equation I was using, what values I was using. I like to use different colored pens when I have them to make things a little bit more organized. And at the very end, I wrote a sentence out. I had 2 things I had to do here. I wanted to make sure that anybody looking at this knew exactly what went with what. I had a total area, and I double checked that it was in units squared, so inches squared, and that my perimeter was just a length. It was just in inches, and I did box it. Now, I am going to put a link to this in the video, so go ahead and look in the video description, and you guys can go and you can look at this and look at it a little bit more in depth. I also took a video of it. Now, this video was made a while ago. All right, so I'm going to make a video explaining practice problem 1. Go ahead and turn it down for now. So I don't really remember everything that's in here. I don't remember if there were interruptions. I don't remember if it needed to be edited and it wasn't edited. But it's about 7 minutes long, me explaining what's going on. And I do encourage students to do this from time to time. You don't have to do it with everything, but if you do a homework assignment and you felt really good about it and you know that it's going to be important and used on a test, go ahead and look over your homework or look over a pre-test, and instead of just looking over it, talk through it and talk through what you did step by step by step. And while you're at it, because they're so easy to have anymore, if you have any type of digital camera that takes video, whether it's a webcam or a tablet or a phone, go ahead and record it. Then you can go and you can rewatch it later, and you can kind of study while just sitting back and relaxing. The second problem is also in here, which there will be a link to that. And I wrote out the practice problem. I tell you that it took about an hour to solve this one as well, and that is not perfect. But I also put a note in here that I noticed there was an error in the video. The final answer on method 2, the decimal is in the wrong spot. I fixed it in the handwritten work, but it is in the wrong spot in the video. And so be aware of that if you do watch that video. And so I drew this picture, and you see that Tom has a head start when they're running a race, and he runs at a constant speed, so he has a straight line. Sally starts at 0, no head start, and she runs speeding up, so she gets faster and faster as she goes, and I say it ends in a tie. A tie essentially means same spot at the same time, so at some given spot, they reach it at the exact same time, and that is a point where time and place meet. I write some assumptions down. I write down what I need to do. I write down my variables. And here for my equation, I start with the position equation like I gave you in the question. But before I even jump into the manipulation stage, I want to change my equation around a little bit. Tom, I know, doesn't have any acceleration, and so I can take the acceleration term out. We can see how that works if I put in 0 acceleration. 0 times anything is 0, so the 1/2 and the t squared go away completely, and I'm just left with my velocity term and my original distance term, my starting distance. I can do the similar thing for Sally. Sally does have an acceleration, but we say that she had no head start, so her starting distance was 0. And we say that she started at 0 meters per second, that she didn't have an initial speed, so that is 0 as well. And so her equation simplifies down as well. Now I solved it 2 different ways. This first way is perfectly okay. I plugged in numbers to get information about Tom. I got that it took 3.47 seconds. And then I used that to get Sally's information, and I got that it was 3.32 meters per second acceleration, per second squared acceleration. And that is an okay way of doing things. Method 2 is better. In method 2, what it does is instead of plugging in my values right away, I combine these 2 equations together. And it might take a little bit of time to look at how this is done. I try to explain it. But what this does is now I have one equation that I only have to plug in numbers into once. And so if I accidentally type in a number wrong into my calculator, I don't have to go and plug in everything again for both of these. If I find out that maybe we gave Tom a 5-meter head start, or that the race was a little bit longer, and if I want to change any of those values, again, I don't have to go back and recalculate everything step by step. I just have this equation at the very end that I can type into my calculator once and get an actual value. And so I went through and I did that, and you'll see that I got 3.32 meters per second squared. Again, same thing. It was the same process, just a different way. Now I do want to show you the error real quick. So this is my video, and towards the end here, you'll see that up above right here, I have the acceleration as 3.32 meters per second squared. But down below, I got 33.2 meters per second squared. To be honest, I even got the right answer here. I wrote it down wrong, and so it's always good to double check things. And so I made this video as soon as I was done. I was really excited. Hey, I got everything good, and I found my error almost as soon as the video was done. I probably actually found it during my video or right as the video ended. And instead of making another, 9-minute video, I just decided to tell you guys, hey, I made an error, be careful. And notice that I did that. So go ahead, you can check these out a little bit more into depth. It's good practice to read through things. Again, these aren't perfect, but they do go through every step. Hopefully they're easy to follow, and that really is the purpose of showing your work.